Let's start. We will talk about Power BI. I will give you an overview about the service. What is it about? How you can use it? How you can use it from .NET developer perspective. I hope people heard about .NET here. You know .NET much better than me, I'm sure. And then what you can do, how you can leverage it for your projects as .NET developer. So why you need to use Power BI? First of all, it's good for your CV, right? Everyone is using Power BI or seems to be using soon. Why it's good? When we talk about data, and we talk about data everywhere now, everyone has data. Medical data, sales data, or if we talk about development, it can be logs data, right? We want to visualize this data, and we want to understand what's going on. We want to get insights, and we need a tool to get these insights, to quickly visualize this data. Or another use case, we want to visualize this data in our web application, and we don't want to develop custom code. We want something which we can use quickly, which we can adapt quickly to our needs, and which we can replace quickly. That's why we might use Power BI. And what is it used for? It's used for data analytics. Data analytics is we use data analytics to explore our data, to extract insights, and to take some actions to understand what we can do to improve, what we can do to prepare. It covers a range of activities, can be different approaches. First and simplest is descriptive analytics. It can help us to answer question, what has happened? We gather data, we have historical data, and we summarize, aggregate, and we understand what's going on. And we can make decision about the future. Next step, diagnostic analytics. Help us to answer question, why things happen. We take findings from the previous step. We can identify anomalies. We can collect more data, and we can dig deeper to understand why things went better or worse. Here we use some statistical techniques to discover relationships and trends, to explain things. Next step is predictive analytics. What will happen? I had actually, it's interesting screen. I had actually a nice circle showing where we use machine learning techniques. These steps are simple. These steps are using statistical techniques. Here we come to ML and artificial intelligence area. When we start to talk about predictive analytics, what will happen in the future? Here we use historical data, we use statistical techniques, we use machine learning techniques, forecasting, neural networks, decision trees, regressions to understand, to predict the future. Next step, prescriptive analytics. What actions can we do to achieve our goals? It helps to make data-informed decision when we have uncertainty what's going on, what's going to happen. Here we definitely use machine learning strategies to find patterns in large data sets. And we analyze past decision, past events, and estimate the likelihood of different outcomes. And next step, most complicated, it's cognitive analytics. How it can be solved best. Here we combine different techniques, artificial intelligence, machine learning, data analytics, and we use self-learning feedback loop. We draw inferences from existing data and patterns. We derive conclusions. and we add these findings back into our knowledge base for future inferences. And our model, our predictions become more and more precise over time because of this feedback loop. To be able to do data analytics, we need a project. And data analytics projects has its own development process as any other project. We cannot just take the data and derive insights from it. We need to understand what we want to do. We need to talk with the business. We need to understand what kind of data we have, what kind of cleaning preparation needs do we have. Maybe we need to add other data sources. We need to explore our data. Then we can analyze our data using those 5 steps approach. We deploy our analytics solution so that people can use it. We collect feedback. Maybe we need to do some improvements, some more data, some more insights, visual improvements, performance improvements. Then we do these improvements and it comes again. And all this can be done in Power BI. Power BI, as we said, it's a bunch of tools to help you do this analytics. And Power BI, I will show you interface. Who has seen this interface? Great. Then it's new for other people. This is Power BI desktop. You can download it for free and start to experiment with data. It all starts with this magical button. You click on get the data. Not sure if I clicked. Yes. And here you can connect to different data sources. You have files, different formats. You have databases, on-premises sources, Azure sources, multi-cloud sources, other services. It has more than 100 connectors to different data sources. You can also combine multiple data sources in one report. You connect, and then you can start to work with the data. Here you have visualization tab. Here you have data tab. You see all your tables. You can click on your tables. You can explore and see what you have. And here you have your model. I'm not sure if you see this properly. Maybe not. It should be like formed as a tables. We will discuss modeling a little bit later, but you see it formed your model as a star schema with the big, large fact tables. I can expand. You see this table, and it is connected to smaller dimensional tables. Who is familiar with star schema design? Yeah, good. So Power BI loves star schema. It's also good test to see if people use Power BI right or not. You open this tab. If you see big flat tables, it's not proper Power BI design. If you have a lot of data, Power BI will be slow. So try to form your data in star schema. It will give best performance. So you get your data, model your data, and then you can build visuals. And here you have report. Report is very interactive. You can select some things. Changes are reflected immediately in other visuals. These parts, charts of the report are called visuals. And all this thing is called report. And create visuals, it's very simple. There are a bunch of built-in visuals. For example, I want to build a chart, and I just drag and drop my data. I want to aggregate sales by customers. Here we go. And I can select, I can see like in my report. And then next step, when I want to share it, something selected there. Yeah. When I want to share with the others, I just click on publish and it will be deployed to Power BI service, SaaS offering from Power BI. And there you will be able to share with the others. Let's come back to our presentation and discuss different connectivity modes in Power BI. So you can, when you connect to data, you can connect using different connectivity modes. Simplest, most recommended is import. You import data from your data source into Power BI. You can select filters, you can select what tables you want to import, and you import. And then the data is stored in Power BI memory database in highly compressed format and gives you the best performance when you interact with your reports. Data is here for you, compressed. You interact with your reports, you define filtering, slicing, the data is queried, and the result is showed immediately for you. You have data and you have model in Power BI report. But the data is not refreshed until you schedule this refresh. So if your data in the data source is changed, the changes are not reflected in Power BI. You need to schedule a refresh. You need to refresh your data yourself. Next is direct query. In this scenario, no data is stored in Power BI. You store only model metadata about your data. What kind of tables do you have? What kind of columns, data types, and so on. And the data is stored in your data source. When you interact with your report, you send queries to the data source. Performance depends on what? On your data source. Your data source should be optimized, of course, and be able to handle load if you have many concurrent users. Why you might need to use direct query? First of all, if your data source is your data set size is huge. And what do we mean when we talk about huge? Who has some understanding how much data we can import into Power BI? We say rows. 1,000? More? Best guess. 2 million. Brave man. More? After billions. It depends. It depends. It depends on your resources in Power BI service, because to be able to import large data sets, you need to have premium capacity, you need to purchase resources and memory. And it depends how much you can put into your memory. If your data model is highly optimized, you use proper data format. You don't store unnecessary data, long strings in your fact tables. Then you can put more data, of course. We say 200 million of rows is not a problem. When we talk about billions, then we have different techniques using direct query, aggregations. We have also demo made of Microsoft product group. They could show that they could visualize 100 terabyte of data in Power BI. The data is stored in data source in direct query. Yeah, the queries are sent to direct query. And they used also aggregation techniques, because when you work with analytics, it's not really often you need to deep dive into specific, for example, order number. You most likely will deal with aggregation, summarization, and so on. All this can be pre-aggregated and stored in memory. It's called aggregations. Then, if you need to deep dive into specific order number, you hit direct query. And to make things more complicated, both import and direct query can be in one model. So you can have some tables, small tables, which are imported into Power BI, and other tables can be used in direct query. It's called composite models. In this case, you can also bring data from different sources into one model. One table can come from one SQL database, another table can come from another SQL database or Excel or whatever. You have 100 connections, you can freely use any of them. One more use case, live connection. In this case, no model is here. Report is just front end, just visualization. And your model in this case should be stored somewhere else. It should be another analysis service engine. Azure Analysis Services, SQL Server Analysis Services, or Power BI data set, which is stored somewhere else. So this is live connection. Live connection is not possible to combine with import or direct query because there is no model in Power BI. And then also very specific also case, which is not here. Power BI is also, it's possible to visualize streaming data in Power BI. So you can stream your data into Power BI, directly visualize it in near real-time mode. It's very handy if you need to see updates very quick. Yes, please. Yes. Yes, data sources can be on premises. Analysis services can be SSIS on premises. For Power BI, it doesn't matter. It can be on premises data sources, can be cloud data sources. Difference is latency. You need to think that the data source can be in the same region to minimize latency because data should be transferred. For on-premises, you also need gateway. Data can be in other cloud. It can be in Google, AWS, and so on. So Power BI can visualize data from whatever. Yes. Yes. You need, if it's on premises or, yeah, you need to have gateway. Yes. Then how Power BI store data if data is imported. So transactional database store data in raw store format. It's a way to quickly append the data to your database. Your data is coming row by row, you put it into your database. What if you asked as a human being to quickly summarize, where is my mouse? Here, unit prices. You won't go row by row, right? Because you see a lot of unnecessary columns. ID, name, color is not interesting for you. You will just go and scan all this column. And the same for the engine, for Power BI engine. Power BI, it would be very slow if it should scan row by row. That's why Power BI stores your data in column store format, where every column is stored separately in adjusted memory locations. And if you need to summarize, for example, unit price, Power BI engine goes to this column, to this memory location, and quickly summarize everything. More than that, Power BI uses different techniques to compress your data. So the data is stored in memory, is usually about 10 times compressed to take less space. There are different compression techniques. I want to say about 2 of them. First is value encoding, and this is mostly for integers with not a lot of range, because if you have big numbers here, Power BI tries to optimize to allocate less possible amount of bytes for every cell. So it takes here, you see lowest number and store it as 0, and then it adds only differences. It stores only difference. In this case, you can allocate less memory for every cell, and then you also save the initial number. And when Power BI does calculations, Power BI just adds this initial number to this difference. It calls while encoding. Not always possible, of course, not possible to while encode strings, for example. In this case, Power BI does hash encoding. What is hash encoding? We create dictionary of all possible strings we have and save it somewhere else in another table. And then in our column, we just save reference to this dictionary. For example, 0 is red, 1 is white, and so on. By doing this, Power BI can also save a lot of memory. Then we already talked about star schema. Power BI loves star schema. And here we have better view with everything is in place. So in the middle, we see fact tables. And fact tables, this table is usually very, very big. It has numbers. In this scenario, this is sales. Here we our sales transactions coming. How order numbers, sales amount, and so on. And here we also create dimensional tables with product, date, and all the strings, category, color, size, which are repetitive for every sales transaction, we save in this dimensional table. And here you also see these lines. These are relationships. How this dimensional table relates to these fact tables. Relationships can be one-to-many, and it means that only one record corresponds to these records in this table. I have only one-to-many relationships. Relationships can also have directions. Here you see a single directional relationship. This is how your filtering in the report will propagate. So if you want to build a report which shows sales for specific product, for example, you have shoes here, you want to select shoes, then in your report, Power BI will filter out sales only for this specific product. Here, for example, you have bidirectional relationships. You always need to consider if you want to use them or not, because they are very memory resource consuming to use. But it's also possible to filter sales order table based on sales table. In this case, you select something here in your report, and a filtering is propagated to this table. Also, relationships, to make things, of course, more complicated, can be active and inactive. And you use DAX code to define, you can tweak which relationships you want to use. You can also build relationships temporarily in your DAX code, not in model. And you can define which of them you want to use in this calculation. Yes, you use calculation and you can program in Power BI. And to program in Power BI, you use very specific language, which is used also in analysis services and Excel pivot tables. So it's called DAX. Anyone familiar with DAX? No one, nice. And DAX is tricky. The DAX is abbreviation for data analysis expression. This is a true programming language, works on tables, columns, and this language is functional. It's made up of expressions that are basically function calls. And it's usually a challenge from for programmers coming from other programming languages. For example, if we compare it to SQL, SQL is declarative language. I don't care how the engine will execute this what I want to get. I just declare a set of data I want to get back, and then I don't worry how to do it. The engine will create query plan, execute it, and so on. DAX is different. DAX is tricky. The order in which I nest my functions and which functions I use, because for one query I might be able to use different functions. It can create different query plan. It can execute differently with different outcome, with different performance. Some queries are executed faster. So DAX really looks easy from the first glance, and simple concept you can learn within hours, and you can start building your reports really quickly. But if you need to work with big models, if you need to work with optimizations, query performance, parallelism, memory access, CPU usage, you really need to invest time into understanding DAX. DAX is not as easy as it looks like. Then we have DAX engine. So when Power BI receives DAX query, Power BI sends this query to analysis services engine, which is all this, which has your model, tabular model, and then it creates, generates and executes query plan. Query plan is executed by two engines. We have formula engine, this one, calculation engine, and then we have storage engine. Formula engine can do calculations, but it cannot retrieve data. Formula engine is responsible for retrieval of data. In case of imported data, if the data is stored in Power BI cache, then it retrieves data from this engine called Vertipack. Funny word, but it's how it's called. And here data is we get data from cache. And as I mentioned, if you want to get fresh data, you need to set up periodic refresh, because data will not refresh itself. Then if you configure it direct query, then request will be sent by storage engine to data source, and then return back to formula engine to do the calculations. Then also we have another tool in Power Query. I will not show demo. I have video recorded. Power Query is also inbuilt in Power BI tool to let you do data transformations. You can connect to multiple sources as in Power BI. You can clean your data, join your tables, add, remove columns, filter, and so on, up to 400 transformations. This tool is very convenient for business users because they cannot program. They can do ETL directly in Power BI. But if you work with huge data sets, it's always recommended to push data transformations close to data source. For example, to your SQL or where you do your ETL processing. So this is how we prepare data, work with model, and build reports. And then when we want to share with our users, we need to deploy to Power BI service. Power BI service is for sharing. Power BI has major building blocks. We already discussed reports, data sets, which is your model. These words are interchangeable. When I say model, I mean data set. Then we also have data flow, I will touch later, and dashboard. And all this is organized into workspaces. Workspaces, you can think about it as folders with different access level. You can configure access level differently for different workspaces. And all these workspaces created on capacities. And capacity is a core Power BI concept. It's a set of resources, storage, processor, memory, to host and deliver your content. By default, all your reports, when you deploy your report to workspace, all workspaces are created in shared capacity. Shared capacity is a set of resources in one Power BI region, which is shared between all customers using Power BI. So it can be performance, depends on if we have, it's a lot of resources, it's a pool of resources, but if it's a lot of usages, there is a risk, might be a lot resource consumption. That's why there are limitations. How big model you can deploy? Only 1 gigabyte model size in memory compressed, you can deploy to shared capacity. And maximum refresh you can do only 8 times per day to ensure fair play. So everyone has sufficient resources. Then you have option as organization, not you, of course, because it's quite expensive. You can purchase premium capacity. Premium capacity has different SKUs, different sizes, but premium resources are resources dedicated specifically for your organization. You will get your own CPU and memory, and you can deploy your content there. And you will also get some premium features. We will talk about it right now. And you, as organization, can still choose if you want to deploy reports to premium capacity, or if your reports are small and don't need the premium features, you can still deploy to shared capacity. And one of the premium features, which is good for us as developers, is XMLA endpoint. XMLA stands for XML for analysis protocol. And the XMLA endpoints gives you possibility to connect to your Power BI data set and interact with it using other tools. And behind the scenes in the background, XML endpoint sends HTTP request and can do write and read operations in the Power BI dataset. You can use a SQL Server Management Studio, you can use SQL Server Profiler, you can use Tabular editor to work with model, and so on. And how we can work with model. And here we see some code. This is your model, and model looks like JSON, but it's saved as a BIM format. You can work in the model in drag and drop interface in Power BI, or you can work with your model as a code, as a team. You can do source control, you can deploy your changes, track your changes, merge your changes, in the same way you work with your other C# or JavaScript code. This is your model, and based on this model, you can create actually multiple reports based on this model. What is also possible, how you can work with model, you can use tabular object model TOM. It's a .NET library, abstract layer on top of XMLA endpoint. So as a .NET developer, you can write C# code in a .NET application to create and modify Power BI data sets directly in Power BI service. And then you can use Power BI REST APIs to do some other operation. You can create data sets, you can clone your reports to another workspaces, you can do deployment, everything. So you have rich APIs and rich possibilities to build and interact with Power BI in your .NET application. You don't even need to go to Power BI service to perform any operations manually. You can do everything with APIs. So this is TOM. TOM is not the same as Power BI REST APIs. They have different functionalities. Some of functionalities are overlapping, but not everything. And in complex projects, you might want to use both of them. And this is how hierarchy looks like for Power BI data set. Top level is server, which is workspace, and then you have collection of databases, which which are your data set, and then you have model and so on. So all of them is possible to change, do modifications or create in your .NET code. To make things more complicated, we discussed data sets, workspaces, then you can have data flow. This is optional layer. You can connect from your data set directly to data source, as I showed. Sometimes you don't want to give people access to data source because it has other sensitive information or cannot handle so much load, or you want to ensure that your data is stored in Power BI. Then you can use data flows. You can set up connection to your data source, data flows. What is data flows? Is another Power BI offering. It stores your data in Azure Data Lake storage behind the scenes. So you can load your data to data flows, and you can do also extract load ETL, extract transform load transformations with your data in Power BI. Prepare your data and let people access it to build their data sets and workspaces. Then you can really build complex transformations in your data flows. You can use enhanced compute engine. If you really need to do complex transformation, you have SQL cache. You can leverage it, and you can build complex structure of your data. You can build data governance and so on. So Power BI can handle really data for the whole organization. Also, we have new offering. I know it's a lot, but I want just to mention. In data flow, you cannot explore your data. You can just transform your data. If you want, let people to explore your data. We have Data Mart. Data Mart is Azure SQL database in the background. Let people bring other data sources, of course, and do ad hoc transformation using SQL or visual interfaces. One more thing, CI/CD. I know time is running, but I want to give you some chance to win T-shirt. CI/CD fully possible in Power BI, and I promise to show deployment pipelines. You can have different workspaces. You can have your artifacts, all your data sets, reports, and so on are called artifacts. And you can deploy artifacts to different workspaces. You can have different permissions to different workspaces and connect to different data sources. Sorry, I'm back. For example, you have really sensitive information. You don't want your developers to see this information, to access this information. They work with test database, and then you deploy to production workspace, and only people who are supposed to see it can see it in production. Developers don't have access to this. I will quickly show how it looks like, because I think it's interesting to see. This is Power BI workspace. You see I have some reports and data sets I deployed here. I can also open report and see this report. But if I click on View Deployment Pipelines, I see I have development workspace, test workspace, and production workspace. In background, I can compare. I see there are new. I can select related, everything deployed to test. When I deploy, I don't deploy data. I deploy only metadata about my artifacts. And when I deploy to test, data will be refreshed there because I can connect my data set to different data sources, to different databases. So this is very simple to use. This is done. I can go to my workspace. The changes are deployed. I teach business users 15 minutes, they start to use it. And they have different workspaces, and they are not scared anymore that they can lose their work. And of course, it uses Power BI REST APIs in background. You can also do these deployments in your preferred tool, for example, Azure DevOps, or where you do your CI/CD. This was this. Power BI Embedded. Here we go. Who has used Power BI Embedded? why we might want to use Power BI embedded. I will quickly show you what does it mean. We go here again. Here's my website. I have authentication for my users. I don't remember where it is, but I have demo account. And here is my application. You see I have some web content, and here I have my report. It's loading, and this is Power BI. And I can navigate, select everything. And what is good, I haven't written any single line of custom JavaScript code, haven't used any JavaScript library to this. I don't need to write unit tests. If my business user comes and says, I want to replace this visual, I don't like this green, I want it to be red, I don't need to redeploy web application. I just go to Power BI, report, changes color, deploy to service, that's it. The changes will be reflected immediately here. This is iframe, which I embed into my web application. And I can also use a bunch of Power BI REST APIs to do filtering from my web application in Power BI report, can show, hide some pages, can do other functionalities. We have Power BI Playground. Here you have test report. You can also use your own report, and you have all possible Power BI REST APIs to play with your report. You can put code here and see the changes. Coming back to my presentation, we have different embedding options. You can embed for your users, in your organization, for your customers. What is the difference? Difference, you need to authorize the users, because you don't want everyone to see your reports. Maybe you have some sensitive data. It's possible to let everyone see it, of course, but in most cases you want to protect your data. You want people to see only what they're supposed to see. And when you embed for your organization, people should log into your web application using their Azure Active Directory login, organizational login. This case, they will be able to access reports in Power BI in the same way as they can do it in Power BI Service. And you also have option to embed Power BI reports for your customers. So you can use it in a web application. For example, if you develop web application with a lot of data, a lot of charts for your external users with your custom authentication, then you can use also Power BI for this. When you embed for organization, as I mentioned, users log in using Azure Active Directory. You go to Azure Active Directory, get Azure Active Directory token, and this token is used to embed your content from Power BI. When you embed for external users, which and they are logged in with some other authentication method, which is developed in your application, doesn't matter which one, then they log into your web application, and then you use service principal or master user account to go to Azure Active Directory, get Azure Active Directory token, and then you use it to get embed token, which in this turn used to access Power BI content. And in this embed token, you can pass content for row level security to define what are your users from different organizations should be able to see in Power BI. Who has heard about row level security? Good. I think this concept is not clear, but I will explain. You will understand. What is row level security? You have a big database with a lot of data, and some rows belong to one organization, one customer. Customer is organization in this case. Can be 100 people logging in. Some rows belong to customer 1, some rows belong to customer 2. When you log in to Power BI and pass this context to row level security to embed token. Then Power BI goes to your source and says, I want to show data only for this customer. Please return me only this data. And then only this data are returned to your report. No other data. So this is very secure. By this, you make sure you show for every customer only data which belong to them, no other data. This is called row level security. If we talk about more advanced scenarios, this is really very advanced. We talk about multi-tenant embedding, and this is nothing to do with Azure Active Directory tenants. Here we talk about Power BI tenants, where you create workspace for every customer, and customer in this case organization. You can create workspaces using Power BI REST APIs. You can create data sets in your application. You have data source credentials for every customer, and you have data source for every customer. For example, you deploy database separately for every customer. And in this case, you can use so-called service principal profiles. Service principal profiles are identities for your customers, which work as their logins. So you have one service principal, and as soon as you add new customer, new organization, you create service principal profile for this customer, and then this profile creates workspaces and reports and all this content, and only this profile has access to this content. Even if they share the same service principal, service principal profiles have different permissions. And why do we want to do it like this? To fully separate content for every customer from each other. They use one web application, they use one service principal, but they have different identities, and they have fully separated folders, tenants in Power BI for their content. Report can be the same. You can clone the same report to every workspace, but they see only their data. They access only their data. This is very secure, and this is for really large scale scenarios when you have thousands of customers, because with one service principal, you can create only 1,000 workspaces, not more. With this scenario, you can scale the solution to really many customers, and I work with customers that do use this scenario. And it's very scalable, it works very secure, and it allows them to fully utilize Power BI for their customers and applications. That's it. Thank you for listening. Thank you.